Hey guys, welcome back. We're going to be looking at our second part of target D, where we're solving exponential equations, but now we're going to be solving word problems. So if we look at example 7, it says, the physical motion of an object is modeled by the function s equals 7.a t to the 1/4. Right? T is the time, and s is the position. So all this is saying, if I know how long something's been moving, I can plug that time in here and it will tell me how far it is, right? And that's measured in meters. So I want to know the time when this distance is 13.2 meters. Round your answer to the nearest hundredth. Okay? So here I just start with the function that it gave me, and then I have this distance, s, so I'm going to plug that in. So I have 13.2 equals 7.8 t to the 1/4. Now if you notice, t is my variable, so that's what I'm solving for. It's just like solving for x, right? No different. So right now, t is being multiplied by 7.18, right? Because when there's no operation, technically there's multiplication between there. So I'm going to divide both sides by 7.8. Right? 13.2 divided by 7.8, that's just from my calculator. And you get 1.69 equals t to the 1/4. Now this is the tricky part. Now, to get rid of that 1/4, I need to raise it to a different power. It's always going to be whatever your denominator is, right? So it's 1/4, so I'm going to raise it to the 4th. And since I raised this side to the 4th, I have to raise the other side to the 4th. So 1.69 to the 4th equals t to the 1/4 times 4, right? And that's why it's always that number. Those then cancel out, and I'm left with just t, right? So when we raise a power to a power, we multiply. That's going back to target 1a, right? Our power rule. So since I have to multiply those numbers, right, I need them to cancel out. That way I'm just left with t, right? And then typing in my calculator, 1.69 to the 4th is 8.16 seconds. So t equals 8.16 seconds. Then, as always, I'm going to check my answer by plugging it back in, right? So this was my answer, and I plug it back in where t is, right? So my left side should be 13.2. This right side, I'm just going to plug into my calculator. And you get 13.18. And again, the answer needs to be close. It's not going to be super exact since we are rounding some of these things, right? We cut off the decimals. So that's close enough, or right, if I round to the 10th place, 13.2 equals 13.2. Let's look at example 8. The physical motion of an object is modeled by the function s equals 9.6 t to the 1/3. Right? And again, t is time, and s is the position. So if I know the time of something, I can find its distance, or if I know its distance, I can find how long it's been moving. Right? And then we're given that our s is 11.7 meters. Okay. So I'm going to start by writing down t to the 1/3, right? My equation. And then I'm going to plug in 11.7 for s. Okay. Everything else stays the same. Okay. So I'm solving for t. So t is being multiplied by 9.6. I'm going to divide by 9.6. And when I divide those two numbers, I get about 1.22 equals t to the 1/3. Now in order to get t by itself, right, whatever this number is, I'm going to raise it to that power. So I'm going to raise this to the 3rd. I'm going to raise this side to the 3rd. So there I get about 1.8, round that up to 2, equals just t, right? Those cancel out. That 1/3 and the 3rd cancel out. So 1.82, and then this is in seconds. Right, so t equals 1.82 seconds. Now again, we need to check my answer. So I have s equals 9.6 t to the 1/3. Right? So I'm still going to plug in 11.7 equals 9.6. And instead of t, I'm going to plug in that 1.82 to the 1/3. Right? So then I get 11.7, and I'm going to type that right side into my calculator. And I get 11.72 or 11.7, right? Since it's in the 10th place, we can round it to there. So those check out. All right, go ahead and pause the video and work on these, try these problems on your own. All right, work on that problem on your own. When you're done, go ahead and continue the video. All right, now looking at our next example, right, example 9 says the area of a circle, if the area A of a circle is known, so I know if I'm given the circle, I know its area. Then I can find its radius, and it's this formula here. R equals A divided by pi to the 1/2. So it tells me the area is 9 pi, and R we know is 3 to the 4x. So I'm going to solve for x. Okay? So here's my formula. I start with that. Okay? Then I know what A is, so I'm going to plug that in for A. And I know what R is, so I'm going to plug that 3 to the 4x in for R. Then I'm going to simplify. So if I have 3 to the 4x, 9 pi divided by pi to the 1/2. If you look here, right, in this next step, I cancel out my pi's, right, because pi divided by pi is just 1. So I just have 3 to the 4x equals 9 to the 1/2, right, and 9 to the 1/2 is 3. Okay, we get to this step here. However, you don't really have to do all of that, because you can just start at this step and type that into your calculator. Right, so I have 9. Pi is down here. Can't see that. So pi is down here, right? Pi divided by pi. Right, so 9 pi divided by pi, all of that to the 1/2. Right? And we also get 3. So we kind of just took out one of those steps. We can just type that into our calculator. Now I have 3 to the 4x equals 3. Right? Now, this is what we were looking at with solving equations. When they have the same base, you can just set them equal to each other. And remember, 3 is really just the same as 3 to the 1st. If it doesn't have an exponent, it's really the same as having an exponent of 1. So now that I have that, right, my bases are the same, they drop out. So 4x equals 1, right? And then I'm just solving for x, dividing by 4, and x equals 1/4. Again, once I have that, I'm going to substitute this x back in here, right? So I have 3 times to the 4 times 1/4 equals 9 pi over pi to the 1/2. I can just type both of these things into my calculator, and we should get 3 equals 3. Let's look at one more example. So example 9. If the area A of a circle is known, then the length of its radius r can be computed by this same formula. R equals area of pi times 1/2, right? So we're going to say A is 16 pi, and r is 4 to the 2x. So I'm going to start by writing out my formula. R equals A over pi to the 1/2. So I'm going to plug in 4 to the 2x for r equals, my a is 16 pi over pi to the 1/2. Okay. So now I'm going to type this right hand side into my calculator. I have 16 pi divided by, sorry, divided by pi to the there we go, 1/2. Right, and if you see, we get 4. So I have 4 to the 2x equals 4. Now, these are the same base, and this technically has an exponent of 1. So really this is 2x equals 1. Divide both sides by 2. X equals 1/2. So let's check our answer. I have r equals a over pi, the 1/2, right? And then again, my r is 4 to the 2x equals 16 pi over pi to the 1/2. Okay. So then I'm just going to plug in my answer for x. So I have 4 to the 2 times 1/2 equals 16 pi over pi to the 1/2. Okay? So then I'm just going to plug both of these things in my calculator. So let's plug in the right side first. I have 4 to the 2 times 1/2. We get 4 there. And on our other side, right, I have 16 pi divided by pi to the 1/2. And we get 4 there. So this equation checks out. All right, and then that's all we've got for part D. So I will see you guys tomorrow.